Hello. So this is a recording for fundamentals of nursing. And in this particular recording, I'm looking at fluids and electrolytes. So fluids and electrolytes. Now, we know that fluids, electrolytes, and acid-base balance within the body is very important. It helps the body to maintain its normal functions. And the characteristics of body fluids influences how the body systems will function and how the cells will be able to function. Now, it's important to note that the characteristics that includes the fluid amount, that is the amount of fluid within the body, both intravascular and extravascular, the concentration or osmolality of the fluid, the composition, that is what is contained in the body fluids in terms of electrolytes, and also the pH are very important in maintaining normal functioning of the body and the cells. So alterations in the characteristics of these fluids can cause an impairment in function. For example, when a patient loses electrolytes, cells will begin to malfunction. So let's begin by reviewing the component of fluid compartments. Now, it is important to remember that about 60% of the body weight of an adult man is actually water. Now, this proportion begins to vary with age, such that approximately 50% of an older man's weight is water. So the total body water begins to diminish as one grows older. Also, obese people have less water in their bodies than lean people because fat contains less water than muscle. Now, the term fluid means water that contains dissolved or suspended substances such as glucose, mineral salts, and proteins. Okay, so when we use the term body fluid, we are actually referring to water that has substances that are dissolved in it. This might include glucose, mineral salts, and proteins. Okay, so body fluids in the body, remember we're looking at body compartments or fluid compartments. We're saying that fluid compartments are contained within two distinct compartments. So we have the extracellular fluid compartment. This one is outside the cells. And then we have the intracellular fluid compartment, which is inside the cells. The extracellular fluid has two major divisions. That is the fluid which is found outside the cells. It is divided into two. We have the intravascular fluid and the interstitial fluid. And then we have a minor division, which is the transcellular fluid. So what are these three divisions of extracellular fluid? This fluid which is found outside the cell. So the intravascular fluid, this is the liquid portion of blood, which is also known as plasma. That is the intravascular fluid. It is contained within the blood vessels. Then the interstitial fluid, this is the fluid that is located between the cells outside the blood vessels. Okay. Then number three, we have the transcellular fluid. This includes fluids such as the cerebrospinal fluid that flows in the subarachnoid space in the brain, the pleural fluid, peritoneal fluid. The pleural fluid is found within the pleural cavity in the chest. Peritoneal fluid, you find it in the peritoneal cavity. Synovial fluid, found at the joints, and of course, secreted by epithelial cells. So these are the different categories of extracellular fluids, three of them. All right. So, what about the fluid compartments? We've talked about the extracellular fluid compartments, which is divided into intravascular fluid. There is also interstitial fluid and transcellular fluid. Now, we're saying fluid in the body compartments contains mineral salts that are technically referred to as electrolytes. Now, what is an electrolyte? An electrolyte is basically a compound that separates into ions or charged particles when it dissolves in water. So ions that are positively charged, if you remember from your chemistry, ions that are positively charged are called cations, and then ions that are negatively charged are called anions. So what are the cations that are contained within body fluids? We have sodium, potassium, calcium, and magnesium. These are among the most important cations that are found within body fluids. Then we have the anions that include chloride and the bicarbonates. So these particular electrolytes are the ones that will combine to make salts in the body. When you are measuring the amount of electrolytes that are contained in body fluids, the unit of measurement that we use is the milli equivalent or millimoles per liter. So we'll say the level of sodium in the body, for example, we can say there is 147 milli equivalents per liter or 147 millimoles per liter. Okay. Now, another important concept regarding body fluids is that of osmolality. So the osmolality of a fluid is a measure of the number of particles per kilogram of water. Because normally you will have this water, and we said that when water has substances dissolved in it, then we refer to it as fluid in the body. Now, the amount of particles per kilogram of water is what we refer to as the osmolality. Now, the particles that cannot cross the cell membrane easily, we refer to these as non-permeant particles. Non-permeant particles, those that cannot cross the cell membrane easily, they determine the tonicity of a fluid. They determine whether a fluid is hypotonic or hypertonic or isotonic. These particles that cannot cross the cell membrane, because if they cannot cross the cell membrane, they will remain, for example, inside the cell, thereby increasing the tone of the fluid within the cell. So a fluid with the same concentration of the non-permeant particles as normal blood is called isotonic. This word isotonic is a compound word. Iso means same. Tonic from tone. So same tone. You're simply saying that same concentration as normal, as normal blood or as plasma. So if you have a fluid, for example, normal saline, and you say this is isotonic saline, what you're simply saying is that the concentration of the non-permeant particles in normal saline is the same as the concentration that you find in plasma. Then a hypotonic solution is more dilute than the blood. It means that the concentration of these non-permeant particles in the hypotonic solution is less than that which is found in plasma. Whereas a hypertonic solution is more concentrated than normal blood. Okay? Having established that, let us now look at extracellular fluid volume imbalances. Now, remember we said extracellular fluid, we are talking about the fluid that is in the blood vessels, which is intravascular fluid. Then fluid that is outside the blood vessels but not in the cells, which is interstitial fluid, and of course transcellular fluids like cerebrospinal fluid and peritoneal fluids, etc. So in an extracellular extracellular fluid volume imbalance, what happens is there is either too little extracellular fluid or there is too much. So when there is too little, we say there is a deficit of extracellular fluid. Or when there is too much, we say there's an excess of extracellular fluid. Okay. So extracellular volume deficit is present when there is insufficient isotonic fluid in the extracellular compartment, meaning the amount of fluid in the extracellular compartment, which has the same concentration as plasma, has reduced. So both the extracellular, because extracellular fluid is both vascular, meaning inside the blood vessels, and interstitial, outside the blood vessels, but not inside the cells, you will notice that signs and symptoms will arise from lack of volume in both these compartments. So the term hypovolemia means a decreased vascular volume and is often used when discussing extracellular fluid volume deficit. Hypovolemia means that there's a decreased vascular volume. The amount of fluid within the blood vessels has reduced. Whereas extracellular fluid volume excess occurs when there is too much isotonic fluid in the extracellular compartment, rather. Okay.
Nothing comes, just transfer or probably
Okay. So when we talk about extracellular fluid volume excess, we simply mean that there's too much isotonic fluid in the extracellular compartment. Okay, that means there's too much fluid either in the intravascular space as well as in the interstitial space, the space outside the blood vessels, but not inside the cells. So those are extracellular fluid volume imbalances. You can either have extracellular fluid volume deficit when there is insufficient isotonic fluid in the extracellular compartment, or you can have extracellular fluid volume excess where there is too much isotonic fluid in the extracellular compartment. Okay. Okay. So let us now discuss osmolality imbalances, having discussed extracellular fluid volume imbalances. What about imbalances in the concentration of those dissolved substances in the fluid? Okay, so an osmolality imbalance in body fluids, in an osmolality imbalance, body fluids become hypertonic or hypotonic, which causes osmotic shifts of fluid across cell membranes. We're talking about fluids that are inside the body. So these fluids, in certain circumstances, when certain pathologies are present, the fluids in the body can either become hypertonic, which means that the concentration of these fluids increases, or they may become hypotonic, which means the body fluids become diluted. So the osmolality imbalances are called, number one, we have hypernatremia, and number two, we have hyponatremia. Okay. So we are discussing, osmolality is discussed in terms of sodium, or in relation to the ratio of sodium to the fluid. So that is why we talk about hypernatremia and hyponatremia when we are referring to osmolality imbalances. Let's talk about hypernatremia, kind of osmolality imbalance, where we are saying there's too much sodium. This simply means it is concentrated, okay? So hypernatremia, also called water deficit, is a hypertonic condition. It means the concentration of the body fluids has increased relative to the normal concentration of plasma. What can cause the blood or the body fluids, the extracellular fluids, to become so concentrated? There are two general causes that make body fluids too concentrated. Number one, it can be loss of relatively more water than salt, because an individual is losing a lot of water and less salt. So the little water that remains will contain a lot of salts. Or this patient is gaining relatively more salt than water. Those are the two general causes of hypernatremia, or a condition where body fluids become concentrated. So when the interstitial fluid becomes hypertonic, this is the fluid that is found outside the blood vessels, but outside the cells. This is the fluid in which the cells are bathing. When it becomes concentrated, remember osmosis. The water that is contained inside the cells will begin to leave the cells to come out into this highly concentrated environment in a bid to dilute it. Remember that water molecules will move from a dilute solution to a concentrated solution. And in this case, we're saying that the water or the fluid inside the cells is less dilute than the fluid outside the cells. The fluid outside the cell is more concentrated. So fluids will shift from the cell to the interstitial space, causing the cell to shrivel or to shrink. So signs and symptoms of hypernatremia are those of cerebral dysfunction, which arise when brain cells shrivel, when brain cells shrink, okay? So hypernatremia may occur in combination with extracellular fluid volume deficits. And this combined disorder is called clinical dehydration, where a patient has been losing fluids, but they are not losing a lot of electrolytes, such that at the end of it all, the little fluid that remains in the body becomes very concentrated. That is clinical dehydration. Now, hyponatremia, which is the opposite now of hypernatremia, is also called water excess or water intoxication. This is a hypotonic condition, unlike hypernatremia, which is a hypertonic condition. What causes hyponatremia? Okay, so it arises from gaining relatively more water than salt, or losing relatively more salt than water. Now, the excessively dilute conditions of interstitial fluids, what will these cause? Let me perhaps do a drawing here, just to make it a little bit clearer. So we have a cell here, okay? We have a cell. Okay, let's do this. Okay. All right, so we have a cell here. And in this cell, there. And the cell has, sorry. Okay, sorry, my pencil is vanishing. Okay. All right. So I think I will just be able to explain it. The pencil has given problems. So when you have a cell and the area outside this cell becomes concentrated, what happens is, I mean, the area outside the cell becomes diluted. We're talking about hypernatremia. The environment outside the cell is dilute, okay? There's too much water outside the cell compared to the inside of the cell. So water will now begin to move by osmosis from outside the cell to the inside of the cell, because the outside is dilute, the inside is concentrated. So the water will move from the dilute solution, which is outside, to the inside, which is concentrated. What will that lead to? It will cause the cells to swell up because they'll accumulate too much water. So as a result, signs and symptoms of cerebral dysfunction will occur due to cerebral swelling or cerebral edema in this case. Okay. So those are the osmolality imbalances: hypernatremia or hyponatremia. Hypernatremia is what leads to clinical dehydration, and then hyponatremia is what may lead to such conditions as edema, for example, and also cerebral edema. Let us talk about electrolyte imbalances, very important. So factors such as diarrhea, endocrine disorders, and medications that disrupt electrolyte homeostasis cause electrolyte imbalances. Now, if electrolyte intake is greater than electrolyte output, or a shift of electrolytes from cells or from bone into the extracellular fluid, this will cause plasma electrolyte excesses. What do we mean? If the intake of these electrolytes is greater than the rate at which the electrolytes are being excreted. Remember, electrolytes are taken through the foods that we eat, through the fluids that we drink, the water, okay? They contain electrolytes. Now, if we take in too much electrolytes compared to how much the kidneys are expelling, then we end up with an electrolyte imbalance. Or if there's a shift of electrolytes, the electrolytes that are inside the cell, for example, move from the cell into the extracellular space, or if those electrolytes that are found in the bone, such as calcium, they move from the bone into the interstitial space or into the intravascular space, that will cause electrolyte excesses. There will be too many electrolytes in the plasma because they've moved from the bone or the cells into the plasma. Now, electrolyte intake less than the electrolyte output, or shift of electrolytes from the extracellular space into the cells or into the bones, will cause the plasma to become deficient, to become deprived of electrolytes, because these electrolytes are moving from the intravascular space, they are entering the cells, such that what remains in the intravascular space or in the blood vessels reduces. So let's talk about the specific imbalances. Let's start with potassium imbalances. So an imbalance in potassium can either be hypokalemia or hyperkalemia. Let's begin with hypokalemia. So hypokalemia is abnormally low potassium concentration in the blood, less than 3.5 milliequivalents per liter. What causes hypokalemia? It results from decreased potassium intake and absorption, or a shift of potassium from the extracellular fluid cells, from the extracellular fluid into the cells, or there could be an increase in potassium output. What are we talking about here? We are talking about reduced concentration of potassium in the blood, in plasma. What can lead to reduced potassium in blood? This can be due to when you reduce the intake of foods or fluids that contain potassium, or when the absorption of potassium is impaired from the GIT, or when potassium, which is in the extracellular fluid compartment, shifts into the cells, leaving the extracellular compartment deprived of potassium, or when there's an increased output of potassium, as the case might be when we give non-potassium sparing diuretics. So common causes of hypokalemia from increased potassium output would include diarrhea. When one has diarrhea, they lose a lot of potassium. Repeated vomiting, they'll lose potassium. Use of potassium wasting diuretics or non-potassium sparing diuretics such as Lasix will cause a decrease in the amount of potassium. Now, hypokalemia causes muscle weakness, which becomes life-threatening, and it includes respiratory. If it includes the respiratory muscles, then a patient might actually develop life-threatening cardiac dysrhythmias. Electrolytes are very important. Potassium is important for muscular function and also for myocardial function. Too little potassium will cause the conducting system of the heart to malfunction, leading to dysrhythmias. Another problem with potassium might be hyperkalemia. Now, hyperkalemia is an excess of potassium in extracellular fluid, which is greater than 5 milliequivalents per liter. So the normal serum potassium levels really range between 3.5 to 5 milliequivalents per liter. Now, in a case where there's too much potassium in the extracellular fluid, this may result from renal failure, okay, from hypoaldosteronism, when there's too little aldosterone, or from the use of certain medications such as potassium chloride. Of course, you are giving potassium to a patient, so the levels of potassium will rise. Use of heparin, an anticoagulant, angiotensin converting enzyme inhibitors, non-steroidal anti-inflammatory drugs, and potassium-sparing diuretics, all these can lead to an increase in the levels of potassium. Now, hyperkalemia can cause muscle weakness, just like hypokalemia. It can also cause potentially life-threatening cardiac dysrhythmias and cardiac arrest. And this is a serious complication of hyperkalemia. Too much potassium will cause a cardiac arrest. It will cause dysrhythmias. What about calcium? So calcium also, you can have an excess or a deficit. So a deficit of calcium is hypocalcemia. There's one thing I forgot to mention about kalemia. Okay, hypokalemia, hyperkalemia. Notice this, that we have the symbol for potassium is the K. Okay. So even the name follows the symbol for the potassium. It's hypokalemia. The K is there. Okay. When it comes to calcium, you do recall that the symbol for calcium is Ca, then with a 2+. So with calcium the name will use the symbol as well, Ca. So hypocalcemia and hypercalcemia. So hypocalcemia is abnormally low calcium concentration in the blood, serum calcium level of 8.9 milligrams per deciliter, or ionized calcium level of 4.5 milligrams per deciliter or less. Okay. So people who have acute pancreatitis frequently will develop hypocalcemia. Why? Because calcium binds to undigested fat in their feces and will be excreted. Why is this happening in pancreatitis? Remember, pancreas produces pancreatic lipase. Pancreatic lipase is responsible for the digestion of fats. So if the pancreas is malfunctioning, a lot of fats will be undigested in the GIT, and calcium has a tendency to bind to these fats. So it will bind to the fats and it will be excreted, meaning the absorption of calcium will be reduced, and this will lead to hypocalcemia. This process decreases absorption of dietary calcium and also increases calcium output by preventing reabsorption of calcium contained in gastrointestinal fluids. Hypocalcemia increases neuromuscular excitability. The neurons begin to overfire. Then hypercalcemia is abnormally high calcium concentration in the blood. It means the serum level of calcium is at 10.1 milligrams per deciliter or even more, and ionized calcium is at 5.1 milligrams per deciliter or more. So what causes excess levels of calcium? These occur it can be due to increased calcium intake or increased absorption of calcium, or it can be due to shift of calcium from the bones into the extracellular space.